This section examines the battery. The wet cell lead-acid battery is the main storage device in automotive use. An automotive battery can supply very high discharge currents while maintaining a high voltage, useful for cold starting. It gives a high power output for its compact size, and it is rechargeable. This section examines producing electrical energy from chemical energy. When two dissimilar metals are immersed in a conducting liquid called an electrolyte, the breakdown of chemicals into charged particles, called ions, results in a flow of electricity. The process is called electrolysis. It is applied in the standard lead-acid battery used in most vehicles. This section examines batteries and cells. Electrochemical cells transform chemical energy into electrical energy. There are two types, primary and secondary. In a primary cell, this transformation is not reversible, and the cell is discarded at the end of its life. In the secondary cell, the transformation is reversible, and it can be recharged. There are two types of secondary cell, wet and dry. In automotive use, the usual main storage device is the wet cell of a lead-acid battery. It has two plates of dissimilar materials immersed in an electrolyte, a solution that conducts electricity by using ions. The accepted or nominal voltage of a cell does not depend on the size of the cell. However, current capacity does. The surface area of the plates in a cell determines its current capacity. In a lead-acid battery, the plates are assembled so there is always one extra negative plate. The plates are close to each other but do not touch, which would cause a short circuit. The nominal voltage of a cell is 2 volts. Cells connected in series make a battery, and the number of cells determines its nominal voltage. The cells are sealed from each other and filled with dilute sulfuric acid. The battery case is usually plastic or hard rubber. One set of plates is connected to the negative side of a DC source, and the other to the positive side. Direct current is applied to the plates, changing them chemically until the battery is ready for service. In a discharged lead-acid cell, the active material of both plates is lead sulfate. The electrolyte is a weak sulfuric acid solution. The cell is connected to a DC source with electrical pressure higher than that of the cell, since it must act like an electron pump, forcing electrons from the positive plates to the negative plates. At the negative plates, sulfate is discharged. More sulfuric acid forms, and the plate changes into sponge lead. At the same time, lead peroxide is formed at the positive plates, which restores the cell's electrical potential. The charging process increases the amount of acid in the electrolyte, making the electrolyte stronger. When further charging no longer makes the electrolyte stronger, charging is complete. Now let's examine discharging. Connecting a lead-acid battery to a load causes chemical changes. At the positive plate, sulfate from the electrolyte joins with lead to form lead sulfate. Oxygen from the plate joins hydrogen to form water. Lead sulfate also forms at the negative plate, as sponge lead forms with sulfate from the electrolyte. Overall, the percentage of acid in the electrolyte falls, and the percentage of water rises, which reduces the strength of the electrolyte. As the cell discharges, the plates develop the same composition, which reduces the potential of the cell.